All right. Here we are. Final session of the day. I hope you're all as excited and filled with energy as I am. I only joke, of course. I am super excited to be here on this slightly wobbly stage. I'm not going to try to think about that too much, about the pit below. All right, so I'm here to talk about web components. What they are, how to use them, and what role they will play in the future of web development. My name is Tobias, and I am from Gothenburg in the west of Sweden. Here I work as a web developer consultant and also part-time as a front-end evangelist at the company Squid. And I will also, of course, take this opportunity to mention that we do have Oslo offices, and indeed, we are actively hiring right now. But I am here today to evangelize, then, as we say, about web components. First, though, let's take a little step back. And I want to talk about an amazing invention that makes our lives so much easier every day. I am talking about ice delivery. What a fantastic service, right? You get ice right to your door. You can put it in your icebox to keep your food cold so it doesn't spoil. If it's a hot day, you can grab the old ice pick and chop off some pieces and put them in your drink. What would we do without ice delivery? Except, of course, no one has ice delivery anymore. Everyone has refrigerators, of course. And the reason why is obvious. A fridge is in every way more convenient. It's cheaper for the customers in the long run. Electricity is a lot easier to deliver than big blocks of ice. When you buy a house or an apartment, the fridge is usually there already, waiting for you. You might even call the electricity a built-in or maybe a native feature of the house. So even though a lot of ice delivery people unfortunately had to find new jobs, moving to refrigerators was clearly an upgrade for everyone involved. And you know what else upgrades? The web. All the time. Sometimes it feels like hardly a day goes by without some new web tech being announced and hyped up. But one of the most amazing things about the web, I think, is its backwards compatibility. Even though new things are added to the specifications all the time, the old stuff still works. If it didn't, then suddenly a lot of old web pages would just stop working. Everyone would have to constantly upgrade and maintain their existing sites. Nothing else would get done. So the backwards compatibility of the web is truly an amazing feature. Let's take a look at another technology, jQuery. What a fantastic library, am I right? When it came around a few years ago, in 2006, it was a tremendous upgrade from the way we used to query and manipulate the DOM. It made web development easier, and in the end, it allowed us to create better experiences for our users. But not many people use jQuery anymore. Well, it's still in use a lot. It exists in a lot of places, but it's hardly the first thing you reach for when you're starting a new project these days, like you would have done maybe 10 years ago. And this is because many of the features and good practices that was established by jQuery made it into the JavaScript and CSS specifications, and thus became native browser features. The functionality that jQuery provided became obsolete. Now we're able to do many of the things jQuery did, but without having to ship a bundle of jQuery code to the users. They already have everything they need natively in their web browsers. And so while the transition away from jQuery to new things may have been a little cumbersome, in the end, it was an upgrade for everyone involved. A little bit like how ice delivery was replaced by built-in electricity. Now let's talk about a technology that many of us probably use quite a lot. JavaScript Frameworks. What fantastic technology, am I right? And I'm talking here about the mostly client-side frameworks like React or Vue, etc. These programs do so much for us, and they enable us to build so many cool things. And there are many problems that these frameworks help us solve. Like they help us keep state and UI in sync. We update the state, the framework automatically updates the UI. We never have to write a DOM modifying line of code again. The frameworks do all this for us, and they do it very well. They also help us with another important thing, componentization. As good programmers, we want to structure our code by splitting it up into logical, reusable chunks of code. I'm sure you know all about the advantages of this. But since there hasn't been a native solution for this on the web, we've had to resort to things like template engines and JavaScript tooling to be able to write componentized code on our end. And then the browser receives a packaged and bundled and transpiled version of this code that the browser can run. And this puts a distance between the code that we write and the code that the user runs. And the bigger this distance, the less control and understanding we actually have of what happens in our applications, and the harder it becomes to ship reliable code. But as long as the tools are reliable, and they are reliable, we still benefit greatly from the componentization that these frameworks enable us. And then there are also additional problems solved by the frameworks like CSS encapsulation or single-page routing and so on. The front-end frameworks are not without their drawbacks, of course. There can be a lot of domain-specific knowledge that you need to acquire in order to understand and work efficiently with your framework. And while rare, they can, of course, ship bugs of their own, which you have very little control over. And then on the user side, we have to include the framework runtime along with our application-specific code, which increases the total amount of data that needs to be downloaded and so on. This has its own set of negative consequences. I'm not going to get into that now. Some frameworks minimize or mitigate this in different ways, but we always have to ship something extra. Enter then web components. Web components are not a magical solution to every aspect of web development. But we will be able to leverage the power of componentization on a native level. This means that in some circumstances, front-end frameworks might not be necessary at all. Sometimes you might find that a combination of technologies produce the best results. But I'll talk more about the use cases later. Let's take a closer look at what web components actually are. Web components are not actually just one thing, but it is a collection of browser APIs that we collectively call web components. The first of these APIs that we'll take a look at is HTML templates. So let's imagine we have, say, a news page, right? And we want to display news articles on this one. And every little article follows the same pattern and has the same markup. It might look like this. A list of news articles, and they're wrapped in article tags, and each of these has a header and some content. And we repeat this for each news item we want to display. Nothing weird there. But of course, when there is new news, we don't want to go in and manually edit this HTML document. So what we would do is maybe render this page on the server. The server would get the news articles from somewhere, a database or a CMS or something, and then calculate the resulting HTML and send it back to the requesting user. Works great, even though there's some extra calculating time on the server, and you have to do this for each individual page. Another thing we could do is to pre-calculate the HTML document so that there is no extra time spent on the server at all, and the user gets a full, complete document right away. This is usually achieved with some form of static site generator and requires one kind of templating language or other. Also, whenever there is a new news article, new news to display, we would have to regenerate these documents before the users can request them. So this is not the best strategy if the data updates very frequently, like if there's only seconds between updates, or maybe even faster. And of course, we can solve it with front-end frameworks that we've already mentioned. We send a minimal HTML page and a script bundle, and then the script fetches the data, doing a little loading animation in the meantime. And then when the data arrives, it renders it out. So these are different ways to solve this little problem, but with HTML templates, we now have an additional option. Here's how we can do it with HTML templates. Right here in our HTML, we can wrap a bunch of markup in the template tag. Everything between these tags will not be displayed on the page, but they will still be available in the DOM. So what we've wrapped in the template tag here is the repeating part of our news page, the list item and the article. In order to repeat and populate the page with these items, we now have to use a little bit of JavaScript. Here's a script on the same page. These first two lines just gets two elements, the list, which we will be putting the news articles into, and the template element. We then take our data, which in a real scenario would come from a backend somewhere, and then for each news item in the data, we do the following. First of all, we clone the template, because it is a clone of this kind that we can append to the DOM so that it becomes visible. But before we make it visible, we modify it by finding the header and paragraph and inserting some content, a title and some text. And then finally, we append the clone to the list. We do this for each data item, and we get a news page with individual news articles. Using HTML templates, we can reuse HTML code using only native browser APIs. We could have done the same without templates. Some of you might be thinking this, by just directly creating and inserting DOM nodes for every iteration. But a HTML template is, one, more performant, and two, it makes use of the declarative nature of HTML, making the code more easily readable, and what you write is closer to what will be rendered in the DOM in the end. Custom elements is the second of the APIs that make up web components. If you take a HTML document and write a tag that doesn't exist, like this tag here, coder greeting, you get nothing. If you put some text content in it, the browser might treat it like a div or a span or something. I think it depends on the browser. I'm actually not sure. But it's invalid HTML and should not be used like that. However, with custom elements, we can make this code valid. Creating a custom element is done with the custom elements registry. To define a new custom element, which is what we do down at the end here, we give the define method a name that will later allow us to write an HTML tag with that name. We also give it a class, which contains all the inner workings of the element. Because it is with JavaScript's class syntax that we specify what our custom elements shall do. We create a class that, first of all, extends the built-in class HTML element. This is required for all custom elements. And then in the constructor here, we set the element's inner text to hello world. And that's that. Now we can write a coder greeting tag here in the HTML, and we get our greeting on the screen. And that's how simple it can be to create your own custom element. In fact, it might not be possible to do it any simpler. Let's also take a quick look at attributes. Any attribute put on the HTML tag can be retrieved in the code with the getAttribute method and then used in the element. So if we put the attribute name on the HTML tag here, we can then retrieve it in the component class. And in this case, we make it part of the element's inner text. And so we get hello NDC. And there's tons more you can do with these, and we'll actually get more into that in a minute. But just remember that the API for a custom element is the same like that of a regular element. Things like get attribute, set attribute, all these things, they're all there. Finally, the third API that powers web components is the shadow DOM. Now, I don't know if it's the name of it or what, but I've gotten the impression that this is like the scariest and the most difficult thing about web components to grasp. But I don't think it is very complicated, really. So let's take a look. Here we have a visualization of a very small document tree. We got an HTML node at the root, and then some HTML elements nested below. Nothing strange about this, all is normal, perfectly ordinary website. Now, you know that we can use JavaScript to attach new nodes to this tree. That's nothing new. But what we can do is we can take one of these elements and attach a so-called shadow root to it. Attaching a shadow root to the body element would make our tree look like this. This doesn't affect the tree in any way yet, but we can now attach more regular nodes to the shadow root, like this. And what we have here is actually a new separate tree. Just like the regular tree has the HTML node as its root, this new tree has the shadow root node as its root. And what the shadow root also does is that it acts like a kind of gatekeeper between the shadow tree and the light tree. The shadow world and the light world. We got a gate between those two. Let's say, for instance, that we put a style tag somewhere in the light tree. A regular style tag for some styling. This styling does not penetrate through the shadow root. Nothing within the shadow world can be targeted by that CSS. And the same goes for styling defined inside the shadow world. Nothing in the light world will be able to be targeted. You also can't query for elements across the border. If you use documents.query selector, you will not find anything that exists on the other side of the shadow root. You will have to find the shadow root itself and then use shadow root.query selector if you want to find things inside the shadow world. There are ways to pierce the shadow boundary and have things like styling come through, but we'll talk more about that in a little while. For now, just know that the shadow DOM is a separate document tree that encapsulates its behavior and does not affect the rest of the document. Okay, now we have looked at HTML templates, custom elements, and the shadow DOM. And so, with our powers combined, we now have the ability to create web components. So let's do exactly that. The component that we will be coding is a custom checkbox. Something you might often find in component libraries, since native checkboxes are notoriously hard to style. It's actually gotten a little easier recently, but to make them truly custom, you still have to do all the work yourself. So, the first thing we'll do is create our custom element. We'll call it cool checkbox because obviously it's going to be really cool. And we'll extend HTML element, just like we're supposed to. Next, we'll define a function called connected callback. You might remember before, we specified the component's content in the constructor. Now, a problem with doing that is that it won't work if the element is appended to the DOM before it has been defined. And this is something that you might want to avoid anyway, but just to be safe and to follow best practices, it is best to do all of the initial DOM manipulation and setup in the connected callback function. Because this function runs right after the element has been both defined and then placed in the DOM. So it is the ideal place for setting up everything that the component needs, its initial state, so to speak. So in this function, we set the element's inner HTML to be an input of type checkbox and a corresponding label. And then finally, we define our element in the custom elements registry, and it's ready to use. We can now put it in our HTML file, like so, and we get a perfectly ordinary checkbox. Awesome. So let's make this web component a little cooler. Let's use a HTML template for the content of our component. Before, we defined a template declaratively in the HTML file, like this, you remember. But we can also do it imperatively with JavaScript. So that's what we do here. We use document.createElement to create a template element. and then we set its inner HTML. And then down in the connected callback, we clone the template content using document.import node and append it to our element. And voila, it looks exactly the same as before. However, the advantage is that if we put multiple instances of our component on a page, the template will only have to be parsed once, and then it can be reused via cloning. So the more copies you have on a page, and the more complex they are, the bigger the performance gain will be. All right, so this was going to be a cool checkbox, and since there's nothing cooler than being dark and mysterious, so I've been told, let's add a shadow DOM. This is done in the constructor, and it's no harder than taking our element and calling attach shadow on it. And there, now we have a shadow root on our custom element. We also pass an options object that contains mode open. And this is so that the shadow root will allow us to access it with JavaScript from the outside. You will probably always do this, set it to open when you create your shadow roots, because it is by accessing it with JavaScript that we can manipulate its content. And that's actually something that we immediately do here in the connected callback function. Here, instead of appending the cloned template content to the element itself, we append it to the shadow root instead. And now we have a shadow DOM. All of the HTML content from the template that was appended to the shadow root is now living in its own little shadow world, having a good old time. If we take a look at the page structure in the browser DevTools, this is from Firefox, we can see the shadow root clearly on display, pretty much like a regular node in the tree. We can expand it, and under each node is a copy of our template, within its own little shadow DOM. Adding some styles to the checkbox is as easy as adding it to the template. We can put a style tag here and some CSS inside that makes the label pink. And as you may notice, we're using a very broad selector here, just label, right? If this was in the light DOM, we might not want to use such broad selectors, but instead use classes and IDs and things to be more specific and target specific elements. But since the styles inside the shadow DOM only affects the elements inside the shadow DOM, we don't have to make it more complicated than this. We only have two elements, as you can see, the input and the label. Also note that the ID on the checkbox is super generic, just checkbox. IDs are also encapsulated in the shadow DOM. So there will be no ID conflicts if elements in the light DOM or in other shadow DOMs have the same ID. This allows us to write CSS that is this simple. We rarely have to bother with classes and naming methodologies, CSS strategies. If we can keep the markup in our template simple, we can keep CSS simple. And keeping things simple is pretty much half our jobs, right? So here is the effect. Very pink, just like the CSS said. Okay, so a web component can do a lot when it comes to deciding its own content. But it wouldn't be very versatile if the user couldn't affect the content and appearance of the component. And there are multiple ways to achieve this. One way is using slots. This is a concept that will be very familiar to you if you've worked with Vue. It's also not unlike the concept of children in React. What a slot is a place in the template that we allow the user to fill with content. We place the slot tags anywhere we want in the template, like right there. And then we put something between the tags of our custom element. It can be text like this, but it can also be any valid HTML. So there's really no limit to this. And the result is that whatever we put between the element tags ends up inside the slot tags. So it's pretty simple, right? It's also possible to have multiple slots and then the user needs to, or then you have to give the slots names, and then the user must use the corresponding names to place different pieces of content into different slots. So that's also possible. The next way to give data to our component is by using attributes and properties. It's important to know the difference between an attribute and a property to understand this. An attribute is what we set on an HTML tag. We can then access this attribute with JavaScript, but it will always be a string. A property is what we have on a JavaScript object. And as you may know, when it comes to the DOM, the document object model, each element in HTML is represented by a JavaScript object. And this is what we get when we use things like a query selector. And this object has properties that we can access and change just like any other JavaScript object. And then the HTML is also updated. So let's say we want to set the text of a label via an attribute instead of a slot. This makes sense in a way, because a label should probably just be a piece of text, right? Well, if we set the attribute on the cool checkbox tags in the HTML like this, that doesn't mean we automatically get a property on the corresponding JS object. We actually have to do that ourselves. So that's what we do here in the connected callback function. We get the attribute and we set it on the element. So that was pretty easy. But remember, the connected callback function only runs once when the element is inserted into the DOM. What if the user changes the attribute? That's where this next lifecycle method comes into play, attribute changed callback. As the name implies, this method fires anytime one of our attributes is changed, and we can then update the property accordingly. It's actually not quite the whole truth. I should say this method runs whenever one of our observed attributes change, and the observed attributes are the ones returned by the getter function that you see here, static get observed attributes. If any attribute in this list changes, then the attribute changed callback will run. And this is because there is no limit to what attributes you can put on an HTML element. You can put whatever you want. So this ensures that we don't run a bunch of code just because of a change to something that we don't even care about. All right, so now whenever the label attribute is set or changed, the property will be updated. Sync achieved. But what about the other direction? If we use JavaScript to change the property directly, we also want the attribute in the HTML to update, right? And even more importantly, which we haven't done yet, we want the actual text on the page to change. This is not something that happens automatically either. So let's make it happen. The easiest way to accomplish this, I think, is to use a custom getter and setter for our property. This is all part of the class syntax, probably familiar to you. The getter for the property is very simple. It just returns the value of the attribute. And then the setter does a little more. Whenever we set the property label, this code is going to run. And the first thing it does is it checks if the new value of label exists at all. If not, then we reflect that change by removing the attribute from the HTML altogether. But if the property does indeed have a value, then we set the label attribute to this value. And we also update the inner HTML so that the change appears visually in the browser. Now the label attribute and property are all wired up, they stay in sync, and they behave as expected. We use it like this, with a couple of different labels there, and it appears just the way we want. All right, so the final way of letting the user affect the content and behavior of our web component is by piercing the shadow boundary. I mentioned this earlier. The shadow DOM and the light DOM are separate, but there are controlled ways to let information slip through. And that's what we're going to explore now. First of all, I'll just add a bunch of CSS here to make the checkboxes really custom. We won't go closer into this because how to style a checkbox, that's pretty much a session in its own. But there is one interesting part of these CSS that you won't find in the light world, the host pseudo selector. This selector targets the host element, that is, in our case, the actual cool checkbox element itself. The container for the whole custom element, really. One reason for targeting this can be to avoid having to use unnecessary wrappers on the top level, because the element is a wrapper in itself. Anyway, this is what it looks like. Now the checkboxes are truly cool, especially when compared to this sad little regular old checkbox hanging out beside. So notice the text color, black, right? Well, take a look at this CSS declaration. Here we set the text color of the label to that of a CSS custom property. But this property isn't declared anywhere, so the color just reverts to its default state. And when it comes to text color, it is an inherited value, meaning it is set to the computed value of its parent. And that's why we only have to set things like color and font family once, usually up on the body element, right? And then this is inherited throughout our entire document. And the reason why I bring this up is because inheritance is one way to pierce the shadow boundary. Inherited values inherit through to the shadow DOM. So if your page uses a certain typeface, your web component will automatically get the same typeface applied to them, without the need to specify this for each and every component. But what about this custom property then? Why is it there at all? Well, custom properties are another way to pierce the shadow boundary, and it's a very controlled one. The custom properties that we use in our internal CSS here in our component, they become the API for the users if they want to change and affect the internal styling of the component. So we can do it like this. This is out in the light world, somewhere in the top of the document. And we have some styling here that sets this custom property, cool checkbox label color. And when we set it out here in the light world, it is then picked up by the CSS inside the shadow world, and the text turns green. And since custom properties can be, they can represent, pretty much any value in CSS, big or small, and they can be reused in many ways. Custom properties provide a quite powerful API that we can expose to our users, allowing them to customize pretty much anything we want. Okay, so we've looked at how a user can send data into the web component to affect things. And now the final thing I want to show you is how to send data from the web component back up to the user. And this is done using the good old browser API events. It might look like this, for instance, in the connected callback function. We find something to react to. In this case, it's our checkboxes change event, but it could be it could be a button press, it could be a network call completion, anything really. And then what we do is we dispatch a new event on the custom element. Notice that it's not on the shadow root, but we dispatch the event on the element itself. And then the user can then attach event listeners to the custom element and react to these elements being dispatched. And it's really that simple. That's how we send data back up. If you're not 100% familiar with the event API, know that in addition to dispatching an event with a name, you can also include any kind of data that the listener can make use of. So we can send both notify that something has happened, and we can send complementary data up to the user. Okay, so this concludes the creation of our checkbox web component. We're using a custom element with a shadow DOM that encapsulates styles. We're accepting user data via attributes and CSS custom properties, and we're sending data back up with custom events. There are, of course, loads more advanced stuff you can do with your web components, but this pretty much covers the basics. I think the main thing to take away is that it is all native browser APIs, and many of these you are probably already familiar with. So hopefully that will make the step to start using web components a little smaller. So now that we've talked about how to create web components, let's talk a little bit about how to use them in different environments and scenarios. Putting a web component in a regular website is as easy as running its registration script once and then placing it in the HTML. This is what we've done a couple of times already in this presentation. Using web components inside client-side frameworks is also incredibly straightforward. As long as you run the registration code once, then you can just use them like you would regular HTML elements. It's super easy and straightforward. The only major exception is actually React, which currently requires a thin wrapper around the components in order for listeners and attributes to work correctly. But this is being worked on, and it will probably be fixed in the next release of React. But other than that, in most major frameworks, it just works. As you've seen throughout this talk, the APIs that we use to create our web components are fairly low level, right? There are many things that need to be wired up manually, and this leads to a lot of boilerplate code. Wouldn't it be easier then if we could make an abstract class that takes care of all this boilerplate code, and then we can inherit from that instead of inheriting directly from HTML element? Well, yes, it would be. And luckily, there are already many clever people who have thought of this and made such classes that we can use. Some have gone even further than that and made really complicated solutions for creating web components. But I think it's safe to call all of these web component frameworks because they make it so much easier and cleaner to write web components. But underneath, they use all of the technology that we've looked at here today. So having that understanding will make it easier for you to understand and use the frameworks. Here are a couple of the most popular web component frameworks right now. Lit is a very competent base class that you can inherit from. It only uses native JavaScript syntax and yet manages to make the API very streamlined. It's a sort of continuation of the Polymer project, which you may have heard of. So I highly recommend checking this out. It's probably the most popular web component framework right now. Stencil includes tooling that makes it easy to write collections or libraries of web components. They also use JSX in their syntax. So if you're coming from React, you might feel comfortable there. And if you're going to create a whole library of web components, this is definitely a library, a framework to consider. And there are also many others out there, like Solid or Lightning or Hybrids, for example, and many more. There are also some of our, should I call them traditional client-side JavaScript frameworks that can actually compile their components into web components, such as Vue or Svelte. I will admit that I haven't actually explored this very much myself, but the possibility is there, just so you know. In conclusion, when it comes to web component frameworks, you will probably want to use one of these when you write web components, at least if you need a moderate amount of complexity or more. They do make things a lot easier, and they don't add a lot of overhead. But again, having an understanding of how web components work on a fundamental level will make it easier to understand what the frameworks do, and it will make you a better developer in the long run, I dare say. Okay, we are nearing the end of this talk, so let's take a moment to look to the future and ask ourselves, what role will web components play in the future of web development? Web components are mature enough and has enough browser support to be used in production today. And they are being used in production in many places. Some people already use web components to build entire complex web apps. Others use them to build single, universally usable components that can be distributed and used in any context. I'd like to show you a couple of examples, actually, of standalone web components that are really quite extraordinary. And I know they would have taken me a long time to build. This is a component by GitHub called relative time. You give it a timestamp, and it outputs a nice relative time, like 5 minutes ago or 2 hours from now. Yeah, you've all seen this. Amazingly reusable. I love this component. And this one, 2up. You give it 2 HTML elements, and they can then be compared with a sliding overlay effect. So it's perfect for, before and after photos or other kinds of comparisons, anything you can think of. Really cool stuff. And how about this one? Model viewer. You give it the URL to a 3D file, and bam, just like that, you've got an interactive 3D model right there in the browser. How amazing is that? I don't even know how amazing it is, because I wouldn't know where to start with something like this. But this is all encapsulated in a single web component. Super cool. Another popular use for web components is, as I've already mentioned, to build UI libraries with them, possibly as part of a larger design system. This makes the library components universal and doesn't force any specific technology on the users of the library. This is especially useful in very large organizations where multiple tech stacks already exist, or where experimentation with new technologies are allowed and encouraged. So you won't have to throw away your entire code base or avoid using the library because the technologies don't match. Or if you want to do a side project with Svelte instead of React at your job. If the UI library is made with web components, you can use them anyway. A question I hear asked is, will web components replace JavaScript client frameworks? Some might claim that web components are here to completely replace or distort the JavaScript ecosystem. Will it be so? Well, not very soon, I don't think. There are still a lot of problems that these frameworks solve that web components in and of themselves do not. Not to mention the huge communities and ecosystems that surround these frameworks. But you could ask yourself this: will React and similar frameworks last and be popular forever? Like forever, ever? Probably not. So what will replace them, and when? Well, regardless of what mine or your predictions are, the fact is that web components are part of the web specification. And that's not going away. Because remember, the web is backwards compatible. In fact, the specification will only keep evolving and improving as time goes by. So, sooner or later, it might be time for you too to upgrade. Thank you. If you want to get in touch with me, my website is there, tobiasljungstrom.net, and you can find me on Twitter as well. Yeah, that's it. It's been a delight. Thank you so much.